Now the adjoint of a square matrix of orders greater than or equal to 3. Now if I have this matrix A here, then the matrix of the cofactors of A is this. So basically this is the cofactor of, wait a second, this is the cofactor of this. Now, if you remember how we find this, let me just recap how we find the cofactor of an element. So the cofactor of A11 here would be -1. So basically A11 is equal to -1 raised to the power 1, the row number, and 1, the column number. And then you'll multiply that with the minor of A11. So how do we find the minor of A11? Well, you'll first delete its row and then you delete its column. And these remaining elements, the determinant of these remaining elements will be the minor. So A2, 2 into A3, 3 minus A2, 3 into A3, 2. This is basically the minor of element A11. And this is how basically you find the cofactor of A11. So you'll find the cofactor of each and every element in this matrix. And then what you'll do is you'll take its transpose. The transpose of this matrix here will become the adjoint of A. That's it. So, in other words, you'll take the cofactors of each and every element and you'll put them in a matrix form, and then you'll take its transpose to get the adjoint. Now, the inverse of a square matrix of order n is equal to or greater than 3. If A is a non-singular square matrix, so basically what non-singular is, if you remember, a non-singular square matrix is a matrix that has a non-zero determinant. And then if A is a non-singular square matrix of the order n, then there exists a matrix B such that when you multiply A with B or B with A, it'll give you the identity matrix of the order n. So it'll basically have the same order. And B is basically the multiplicative inverse of A, and it is denoted by A inverse. So what B is basically, if you multiply A with its inverse, it'll give you the identity matrix, or if you multiply the inverse of A with A, it'll give you the identity matrix as well. So that's one way to deal with inverses. Now, the other way is, if A is a non-singular square matrix, then what you simply do is you'll divide the adjoint of A with the determinant of A, and that's about it really.